Okay, September 30th, 2011, lesson 2.2, page 74. We're working on the length of a line segment. So they're going to give you a formula that goes something like this. The distance of a line segment is equal to x2 minus x1 squared plus y2 minus y1 squared. All of that square rooted. So, this formula, we're going to obviously need 2 points. We have a y2 and an x2 and a x1 and a y1. We'll plug them in to find the distance of a line. So, let's start off with the basic idea. Let's say we have a coordinate, we have 2 coordinates. One will be -3 and 5. We'll call that coordinate A. And coordinate B will be 2 and -4. Okay? So first thing I need to do is I need to call them coordinate 1 and coordinate 2. It doesn't matter which you call which. Just make sure you stay consistent when plugging it into the formula. This will be our x1, y1, x2, y2. Now we're going to plug these into the formula. x1 will go here. x2 will go here, y1 and y2. So, the formula is the distance of a line segment is equal to the root. And that's a square root of x2, which is 2, subtracted by x1 is -3, and that's squared, plus y2, which is -4, subtract y1, which is 5, squared. From there, our variable's on the outside, it's d, that's what we're trying to solve for. We just have to equate everything. So, I end up with 2 subtract -3, which is the same as adding 3. So, I end up with the number 5 squared, plus -4 minus 5 will actually give me -9 squared. D is then equal to 5 squared is 25, plus -9 squared is positive 81, because we're multiplying 2 negatives. D is equal to the square root of 25 plus 81, which is 106. We'll fix that. That's supposed to be...
Leave it here.
Sure. That's a 0. And then we find the square root.
Who's not using the hand sanitizer in this room?
Okay, 106 squared, the square root of 106 is approximately 10.3. Now, what I want you guys to do with this,
Oh my God.
so, we're going to deal with the same idea, the exact same question. Now, we have that formula, D is equal to, we had x2 minus x1 squared plus y2 minus y1 squared, and all square rooted. What I'm going to do is I'm going to plot this because it's easier to show what I'm talking about when these points are plotted. A is -3 and 5. B is +2 and -4. Now we already discovered that the length of this line was 10.6. Okay, so we have our line, which we've already discovered the distance of it. Now, what I'm going to do is I'm going to slowly take apart this equation to relate it to another equation, okay? And we'll do it at the bottom here. Our equation was D was equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, what I want to show you guys is, remember, these are our x points, right? We know it goes from -3 to +2. That distance there, I'm actually going to draw a line from one end to the other. And then, from the highest point to the lowest point, I'm going to draw another line. what I've created is a right angle triangle. Okay? And what I'm looking for is the hypotenuse of that right angle triangle. So as long as I know the distance of each of the other sides, which we do by subtracting, we went from -2 to +2. So how far is that distance?
5.
4.
Close enough.
Is that the right distance? Oh, sorry, we're going from -3.
There you go.
We went from -3 to +2, so it's 5.
Hey!
And we go from +5 down to -4, so that distance is 9. So, what I can use, what other formula can I use, Franklin? Pythagorean Theorem. So, if you guys recall, Pythagorean Theorem is c squared is equal to a squared plus b squared. I want you guys to look. I'm going to call DC now, and I'm going to bring the square root over. How do I bring a square root sign over? How do I cancel it on one side? I have to square both sides. Okay? So when I square both sides, I end up with c squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And we did y2 and y1. Sorry, here is our x1 and x2. We subtracted them to find 5. That was our a. And our y2 and y1. We subtracted those two to find 9, which is our b. So I'm going to replace x2 minus x1 with a and y2 minus y1 with b. So this distance formula is essentially Pythagorean Theorem. They just use different letters, and they give you the x2 minus x1 and y2 minus y1 to solve. If you plot these points and create a right angle triangle, you can use Pythagorean's theorem to find the distance of any line segment. Okay, so what I've done is I've graphed the triangle. It always helps if you have a visual in order to understand the question. Question says determine the length of the median from vertex J in the triangle with those vertices. I've already plotted those vertices. And it says the median has to be from point J. Well, the only way I can create a median from point J is if I find the midpoint of KL and draw a line from vertex J to midpoint between K and L. So, first thing I need to do is use my midpoint formula, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And we look for K and L, -3, 2. And L is 1, 3. I'm going to name these point 1 and point 2. So this will be my x1, y1, x2, y2. So we have our x1 and y1, x2 and y2. We're going to plug these points in. Our x1 was -3. Our x2 was 1. Our y1 was 2. And our y2 was 3. We equate the midpoint. -3 plus 2 is 2 over 2. And 3 plus 2 is 5 over 2, which is essentially 1 and 2.5. Or you can leave it as an improper fraction. I would prefer to, personally. But next, what they've done, now that we have that point, our point is at, what did we say, 1 and 2.5? Oh, sorry, negative. Yeah, I was going to say, that didn't make any sense. -1 and 2.5. They want us to find the median, the distance of our median. So our coordinates are -1 and 2.5, which is our, we'll call it M. And J was -2, -2. So we're going to use our distance formula now. This is our M coordinate, and our J coordinate was -2, -2. our distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, I'm going to have to name these points. We're going to call midpoint 1 and J2. So x1, y1, x2, y2. And we're going to plug these points in. Our distance was equal to the root of x2 is negative 2. Subtract x1 is negative 1. So we're subtracting negative 1 squared. Plus y2 is negative 2. Minus y1 is 2.5 squared. D is equal to the root of negative 2 minus negative 1 is like negative 2 plus 1. So I end up negative 1 squared. Plus negative 2 minus 2.5 is going to give us negative 4.5 squared. Negative 1 times negative 1 is 1. We have the root of 1 plus negative 4.5 times negative 4.5 is the same as 4.5 squared. 20.25. We add those two numbers together. 21.25. We're finding the root of this number. D is equal to... Is that what it is? 4.6. Beautiful.
See, that's what I was thinking.
Can I write it before?
No. That wouldn't even be properly rounding. Okay. So the distance of our median is 4.6. They haven't given us any unit of measurement, so we're just going to call it units. Okay? 4.6 units.